Hi, I'm Chris, and we're taking a look at this year's PSAT Math Section 2, question number 20. This is the last question in this math section, which oftentimes indicates that it's going to be the hardest, and I think from this year's PSAT that it was. A lot of students right after the exam asked about this question and wanted to know how you go about solving this. So let's take a look here. Here we have a diagram, and I filled in the information from the question. They want to know in this diagram what the length of DF is, which let me fill that in here. This is point C and this is point D. So DF is this line here, and that's the line that we have to solve for to see if we can find that length. So they tell us each side is 4, and they tell us that the coordinates of point A are 4, 0, which indicates that this is 4 units long here. And so there's a couple things that we can do here in order to figure out what that length is going to be. The most important thing, equation-wise, for us to know on this is whenever you're dealing with a polygon, 180 times n minus 2 is the sum of the interior angles of that polygon. And for this particular polygon, there are 6 sides. So if we were to plug in a 6 into this equation, we would have 180 times 6 minus 2, which is 180 times 4, which is 720. So the sum of all 6 of these interior angles is 720 degrees. To find one of the interior angles, you simply have to divide by the number of sides that there are. So 720 over 6 gives us 120 degrees. Now that's important because for us to figure out what the length is going to be, we need to figure out what types of triangles we're dealing with inside of this hexagon. And here, if we were to take a look at this angle, each of these individual angles is 120 degrees all the way around the hexagon, which means here, if we were to convert this into a right triangle, when you split 120 in half, you get 60 and 60, and that means that each of these would be a 30, 60, 90 right triangle. Now, if you turn back to the beginning of the section, you'll see that the SAT and PSAT will be really nice, and they'll give you a little chart that gives you equations for area of a rectangle, Pythagorean theorem, area of a circle, circumference, and they also will give you your special right triangles, 30, 60, 90, and 45, 45, 90. Ideally, by test day, you want to memorize this information. It, frankly, in the context of a standardized test where it's timed, it takes too long to go and look it up. And for more advanced questions, you're really going to need to know that information to answer those accurately. So here, if we have a 30, 60, 90 right triangle, the hypotenuse is 2x, which means it's double the shortest side. And your short side is x. So here, x would be 2. And then your longer leg will be x root 3, and in this case that will be 2 root 3 for this portion of df, and this portion of it will also be 2 root 3. So when you piece those together, 2 root 3 plus 2 root 3 will give you 4 root 3 for the length of df. So the most important thing to take away from this, the formula for the sum of the interior angles and the relationship between the sides of a 30, 60, 90 right triangle, which I'll put over here real quick. If you have a 30, 60, 90 right, your short side is x, your hypotenuse is 2x, and that longer leg will be x root 3. For more, please feel free to take a look at our other videos, and thanks for watching.